So in this video, we're looking to find the residues of this function here, e to the z minus 1 over 2z squared minus z minus 3. And as always, complex analysis, because we got the z is a plus bi, where a and b are real numbers, and I is the square root of minus 1. Okay, so find the residues of this. Well, first of all, we'll help if we can find singularities. So let's have a look at the singularities. To find out where this can be 0, let's factor it and see what we get. So this is e to the z minus 1, that can stay. 2z squared minus z minus 3. So factor that out. We've got 2z and we've got a z and we got a 1 and a 3. So if we have a plus 1 times 2z and the z times minus 3, that gives minus z. So 2z minus 3, z plus 1. Okay, so that's that factored. Now we can find the singularities. So the singularities to make this disappear is going to be z equals minus 1. So there's our first singularity. So singularity z equals minus 1. And this one here, z will be 3 over 2. 2 times 3 over 2 is 3. 3 minus 3 is 0. Z equals 3 over 2. Okay, and then what we can say is that these are all to the power of 1. Going to put an imaginary 1 there. These are simple poles. So let's just write that down there. These are simple poles. Okay, now we need to apply the residue theorem. So how are we going to do about that? So the Lorentz series, a bit complicated, a bit messy. Best way to use this would be like in the cover-up rule. So for the cover-up rule to be valid, we need to know that this is analytic everywhere. So we do know this is exponential and this is polynomial. So we know, yeah, this is analytic everywhere. So cover-up method. So f is analytic everywhere. So that ticked. Next problem we've got is we need the bottom ones here in the form of z plus or minus alpha. So denominator is in the form of z plus or minus alpha. So this one's okay. This one, a little bit of work to do. So let's just change that one now. So e equals e to the z minus 1. Take this 2 out. Then we go in the form of z plus or minus alpha. So 2z minus, divide that by 2. That's 3 over 2. And z plus 1. Again, we've got our simple poles at minus 1 and plus 3 over 2. Okay, so now all we have to do now is make each one cover up, plug in the values of each of our singularities, and away we go. So the residue of f, let's do minus 1 first. That equals, plug in minus 1 for all these values. E to the minus 1 minus 1. 2 stays, obviously. Z is minus 1. So minus 1 minus 3 over 2 is minus 5 over 2. And obviously this one disappears. Minus 1 plus 1, 0. Okay, all these is now is just to do this, finish this off. That's e to the minus 1 minus 1. 2 times minus 5 over 2. That's minus 10 over 2, which is minus 5. Okay, so we can do some nice little algebra here. We can multiply by the minus 1. That will give us 1 minus e to the minus 1. Again, these will just switch places because they get a minus there and a minus there, which gives us plus. And minus minus 5 is 5. Now here, e to the minus 1, don't be tempted to write 1 minus 1 over e over 5, which equals 1 minus 1 over e times 5. Obviously you get a 0 on the top. Now this is clearly not 0. 1 minus e to the minus 1 is something around about minus 0.6, 0.7, something like that. So what we can do is we can multiply top and bottom by e. So if we do that, what we're then left with, let's just make sure we know that these are wrong. That then gives us e times 1 is e, minus e times e to the minus 1, well that's just 1, and 5e. Okay, so that's our residue at f minus 1. So that's taken care of. So that's our answer for that. This, no good. Now we've got z equals 3 over 2. So residue of f 3 over 2. So all that's left to do now is to plug 3 over 2 into our formula here. So it's making sure this is not part of the calculation, that's just part of this one here. E to the 3 over 2 minus 1. Again, we're just plugging 3 over 2 for all the e's. 2. 3 over 2 minus 3 over 2, this is the one that we're covering up. 3 over 2 plus 1, that's 5 over 2. Okay, now let's just clean that up a little bit. E to the 3 over 2 minus 1. 2 5s are 10 over 2, that's 5. That gives us our answer to that one. Okay, that's our residues of f3 over 2 and f minus 1. That's this one and this one. Okay.